Morning class. Today we're going to be testing solutions to figure out whether they're ionic or covalent. Ionic bonds will be able to generate a substantial electrical current, whereas covalent bonds, not so much, very little to no current. We're going to be testing with two different instruments today. This very simple electrode-based instrument from Flint Scientific with a convenient red and green light, and this fancier probe that I ordered from Amazon, an electrical conductivity probe. So here's our solutions. We're going to start with distilled and tap water. Distilled water should be close to zero because distilled water has had all of the minerals taken out of it. I'm going to test my meter, turn it on, and test it with a copper penny. So here we see both lights coming on. If we look at the scale, a very bright red light and a medium green light signals very high conductivity, which this is a metal, it's copper. Let's try the distilled water. As you can see, there's very little signal, little to no signal. And I'm going to use my rinse, which is also distilled water. Whereas tap water, we see that bright red light come on because the tap water does have some dissolved minerals in it, some contaminants. So a medium red light with the green light off, that's a medium signal, or scale of 2. So distilled water, we have a conductivity reading of 0. Tap water, we have a 2. And let's go ahead and use the meter. Put it in EC mode, electrical conductivity, which is going to be in microsiemens per centimeter. For distilled water, that's an 8. I'm going to rinse it. And for tap water, wow, it's going pretty high. 186. Rinse it off. You can also see in the rinse that the electrical conductivity is going down to a 32. It looks like my rinse is a little bit contaminated. So for the distilled water, it was 6. Tap water is 1148 microsiemens per centimeter. Rinse and test my other solutions. Make sure that both of my probes are rinsed. I'm going to start with the copper sulfate, which is the next in our table. Copper sulfate is giving me a green and red light. That's a 4 on the rating scale. Magnesium sulfate, also a 4. Make sure that your indicator light is not on in between readings. Next in the table we have sodium chloride, also a 4. Those are ionic compounds because we know they have a metal and a non-metal. They transfer those electrons to one another. Potassium iodide is also a 4. Let's rinse our probe. Sugar is next, glucose. No signal. That's no signal at all, hardly even a red light. That's a true 0. And last, isopropyl alcohol, also a 0. I'm going to test my copper penny just to make sure everything was running right because I got some zeros there at the end. Copper penny still coming on, and there's the bell. Let me test my electrical conductivity before everybody comes in. Copper sulfate, put it in electrical conductivity mode. Copper sulfate, 694. And rinse. 694 microsiemens per centimeter. Next is magnesium sulfate, We have, and climbing, 12, 1300, 1310, and rinse. We want to make sure we go into 0 in between. Sodium chloride. That is a 1300 in climbing. Be patient. 1400 in climbing. Still going. Sodium chloride is a strong ionic compound. 1482. Potassium iodide. Oh, super strong. We're in the 4000s there. Very strong. 5000. And climbing. Looks like it's going to be about 5096. Sugar, we're not expecting much because we got a 0 on the Flynn reader. Sugar. Very low, 6. And alcohol. Also expecting something low. Not as low. We're in the 800s. 840. I'm going to verify my copper sulfate. Oh, I tested the wrong one. So that was copper sulfate. That makes more sense. Alcohol is also 0 microsiemens per centimeter. Always double check in the lab.